Running a Fever, episode 395, Aging Reversed, part 8, Future Medicines and Technologies. Welcome to Running a Fever. I'm Michael Davis. This is a podcast about fitness, diet, and medicine. My goal is to live a long, healthy, happy, active life right up to the very end. And I'll do it by loving my life enough to make it last as long as possible. And just how long can life last? Who knows? At least one person has lived to be 122, so we know that's humanly possible. Physicist and Nobel Prize winner Richard Feynman said, "There is nothing in biology yet found that indicates the inevitability of death. This suggests to me that it is not at all inevitable, and that it is only a matter of time before biologists discover what it is that is causing us the trouble." In this series, called Aging Reversed, we're talking about some ways to get there from a genetics point of view. Thus far, we've covered aging as a disease, the information theory of aging, longevity genes, calorie restriction and fasting, exercise and longevity, and cold and heat exposure. Today, we're going to explore the world of medicines and medical technology that's discovery and development may be just around the corner. And we'll talk about some that are available now. I expect this may be the most popular episode of the series because we're all looking for a shortcut. And if we can just take a pill to stop the disease of aging, what could be easier? Fountain of youth, right? A molecule known as rapamycin was discovered on Easter Island in the mid-1960s. It had several desirable qualities, including its antifungal ability, as well as its ability to suppress the immune system. It is now used to reduce rejections in organ transplants. But it also has the ability to extend life. It has been tested in yeast cells, worms, fruit flies, and mice, and extended the life of all significantly. Mice can live 9 to 14% longer when given rapamycin in small doses near the end of their natural lives. It also stimulates production of NAD, which we know from previous episodes in this series fuels the sirtuins that keep our DNA in line, thereby reducing the effects of aging. Rapamycin works by inhibiting the production of TOR, T-O-R, which just means target of rapamycin. We mentioned it back in part 4 of the series. Why would you want to inhibit it? The problem with TOR, or specifically mTOR as it's called in mammals, is that it must be delicately balanced. Too much can cause diseases like cancer, cardiac hypertrophy, and psoriasis. Too little can cause liver disease, muscle atrophy, and delayed healing. When inhibited just enough, though, TOR causes the kind of cellular distress that puts cells into survival mode and extends life. Rapamycin does just that. Unfortunately, rapamycin can be harmful. High doses can cause kidney disease over time, and the same immunosuppressant qualities that help with organ transplants could be dangerous otherwise. Scientists are currently working on finding compounds that act like rapamycin but are less dangerous. In the 1950s, a drug derived from lilac plants, dimethylbiguanide, was found to be effective in treating type 2 diabetes. The drug, now commonly known as metformin, is extremely safe, effective, and cheap, and in wide use around the world. But there's more. Recently, a National Institutes of Health lab found that even low doses of metformin extended the life of mice by 6%. They also showed reduced levels of LDL cholesterol. 25 out of 26 studies of mice on metformin showed protection from cancer. One study of over 41,000 metformin users demonstrated that metformin reduces the likelihood of dementia, cardiovascular disease by 19%, cancer, frailty, and depression. Like rapamycin, though much safer, it also increases production of NAD. Unfortunately, metformin is considered a drug and is regulated as such, and since aging is not considered a disease, you can't get it for that purpose. If you have diabetes, it should be easy to get a prescription. But even if you are pre-diabetic, it will be hard to do so otherwise. But there is hope. The FDA has agreed to consider aging as a treatable condition if a particular study is successful in showing metformin has measurable benefits. That study is called Targeting Aging with Metformin, or TAME. So we'll be definitely following that. Sirtuins are enzymes in the epigenome that are responsible for turning on or off the various genes in DNA. When one scientist was researching ways to inhibit the sirtuin SIRT1, he discovered two chemicals that activate it instead, making it work faster. They are known as SIRT1 activating compounds, or STAC. He showed his work to a chemist who noticed they had the same structure as resveratrol. Resveratrol had hitherto been known as the antioxidant in red wine, thought to be the reason the French had low rates of heart disease despite eating a lot of fatty foods. David Sinclair experimented with resveratrol on yeast and found that it worked even better than the other two chemicals at activating SIRT1. The yeast-fed resveratrol became smaller and grew more slowly. This mimics calorie restriction. See episode 392 for more on that. And the yeast lived longer, the equivalent of 50 human years longer. When tested on insects, their lives were extended the equivalent of 14 human years. A similar experiment on mice yielded a 20% increase in lifespan. In other experiments, researchers found that resveratrol protects mice against many cancers, heart disease, stroke, heart attacks, neurodegeneration, inflammatory diseases, and promotes wound healing. Resveratrol is available as a supplement. However, it has potency problems and is vulnerable to attack by the immune system. It is also not absorbed well in the human gut. On to NAD, or nicotinamide adenine dinucleotide. We already know that NAD is fuel for sirtuins. It is considered a STAC as well, but activates not just SIRT1, but all sirtuins. There are molecules that can boost NAD. One of these is nicotinamide riboside, NR, which is found in small amounts in milk. It is a form of vitamin B3. NR has also been found to extend the life of yeast by boosting NAD, which in turn activates the sirtuin SIRT2. NR is readily available as a supplement for less than a quarter per 1,000 milligram capsule. Nicotinamide mononucleotide, NMN, is a chemical compound made by our cells from NR. It is also found in foods like avocado, broccoli, and cabbage. NR and NMN, when taken as a drink, can boost NAD levels 25% over 2 hours, which is the same effect you would get from exercising or fasting. NMN is an amazing molecule. In 2011, Shinichiro Imai demonstrated that NMN could treat the symptoms of type 2 diabetes in old mice by restoring NAD levels. Another lab showed that NMN treats a form of type 2 diabetes in obese female mice and their diabetes-prone offspring. And in 2017, scientists found that mice dosed with NMN could run over 3 kilometers at a time. Other labs have shown that NMN, we're talking about a mouse here running 3 kilometers, not a human. Other labs have shown that NMN can protect against kidney damage, neurodegeneration, mitochondrial diseases, and an inherited disease called Friedreich's ataxia. So far, no adverse effects have been seen from taking NAD boosters like NR and NMN. There are hundreds of molecules like the ones I have described being researched right now, and thousands of candidates for future study as well. Who knows what the future will bring? Perhaps a combination of these supplements along with caloric restriction and exercise can extend our lives years or even decades. There's much more to learn and much more to see. To me, this was one of the most compelling episodes to research. I hope you got something out of it as well. There's a lot of technical information here, so if you want to review it in more detail, see the sources as well, go to runningatfever.com/395 to read the blog post. That's it for today. Remember, if you got the fever, keep it burning, and if you don't, catch the fever, and I will see you next time on Running at Fever.